Okay, now comes the topic of integration. Integration is basically a way of adding slices to find the whole. It can be used to find the areas, volumes, central points, and many useful things. But it is easiest to start with finding the area under the curve of a function like this. Now, what is meant by slice? We could calculate the function at a few points and add up the slices of width delta x like this. If this is basically area under the curve, I have to find out the area under this curve. I can divide this interval into small slices, small rectangles whose width is delta x, and this can also be another way. So we can make delta x a lot smaller and adding up many small slices to get a better answer. As the slices approaches zero in width, the answer approaches to the true answer. We are writing dx, that means that it is del x. Slices are approaching zero in width. This is a lot of adding up. So we don't have to add them all, as there is a shortcut, because finding an integral is the reverse of finding a derivative. So if we want to find the integral of this function 2x, then the integral of x square is the integral of 2x is x square, and the derivative of x square is 2x. So we know that the derivative of x square is 2x, so the integral of 2x is x square. So this is the integral symbol. This is the function we want to integrate. Dx is slicing along x. So after the integral symbol, which is for basically sum, the idea of summing the slices, we put the function we want to find the integral of. That is called the integrand. And then finish with dx to mean the slices go in x direction, approaches zero in width. Basically, there are a lot of applications of integration in engineering. For example, the electrical engineers used integration to determine the exact length of power cables needed to connect the two substations which are miles away from each other. It's also used in medical sciences. Biologists use differential calculus to determine the exact rate of growth in a bacterial culture when different variables such as temperature and food sources are changed. These are used in physics to calculate the center of mass, center of gravity, mass, and moment of inertia of sports utility vehicle. It is also used to calculate the velocity and the trajectory of an object, predict the position of the planets, to understand about electromagnetism. It's also used in statistics, it's used in graphics. So there are a lot of practical applications of integration. For example, if a swimming pool is rectangular with a flat bottom, then from its length, width, and depth, we can easily determine the volume of water it can contain, the area of its surface, and the length of its edge. But if it is oval with a rounded bottom, all of these quantities called for integral. So the simplest case, the integral over x of a real valued function is written as integral f of x dx, where the integral sign represents the integration. The dx indicates that we are integrating over x, and x is called the variable of integration. Inside integral d of x is the expression to be integrated, that is called the integrand, and in this case the integrand is the function. Because there is no domain specified, as there are no limits, the integral is called the indefinite integral, and the process of finding a function given its derivative is called the integration or anti-differentiation. When integration over a specified domain we speak of definite integrals. Integrating over a domain D is written as integral from a to b f of x dx. So if the domain is an interval ab of x, the domain D or the interval AB is called the domain of integration. If the function has an integral, it is said to be integrable. In general, the integrand may be a function of more than one variable, and domain of integration may be the area, volume, or a higher dimensional region. These are the integration formulas. Here comes the rules of algebra for the antiderivatives for the indefinite integrals. That if a constant is multiplied with a function, you can take out a constant outside the integral sign, and if negative sign is multiplied with the function, then the negative sign is also multiplied with the antiderivative. If two functions are being added or subtracted, then the integral, being a linear operator, is applied on both the functions. Then comes the rules for the definite integrals. First is the order of integration. You can reverse the order of integration by adding a negative sign. Zero width interval. If the upper limit is a and the lower limit is also a, then without solving, you can say that as the width of the interval is zero, so the area under the curve is. If a constant is multiplied with a function, you can take out constant. If two functions are being added or subtracted, then integral can be applied term by term as it's a linear operator. As integral is applied from a to b and then from b to c, then using the property of additivity, we can say that integral is being applied on the interval a to c. Here we have to write a to c instead of, it's a mistake. Now comes the min-max inequality, that if a function has a maximum value capital F of x and minimum value small f on the interval a b, then the integral of that function lies between the maximum and the minimum value. Here comes the domination, that if the first function f of x is greater than equals to g of x on the closed interval a b, then the integral of f of x will also be greater than g of x. Now here is an example that show that the value of integral 0 to 1 under the radical 1 plus cos x dx is less than or equals to under the radical 2. So we can apply the min-max inequality for the definite integrals, which says that the minimum of the function multiplied by b minus a is the lower bound for the value of the function integral a to b f of x dx, and the maximum of the function multiplied by b minus a is the upper bound. So the maximum value of the function under the radical 1 plus cos x on the interval 0 to 1 will be 1 plus 1, that is equals to under the radical 2. So under the integral 0 to 1 under the radical 1 plus cos x dx will be less than equals to under the radical 2 into b minus a, that is 1 minus 0, so it is equals to under the radical 2. Now comes area under the graph of a non-negative function. If y is equals to f of x is a non-negative and integrable function over the closed interval ab, then the area under the curve of the function over the interval can be written as a is equals to integral a to b f of x dx. And now comes one of the important application of the definite integrals, which is basically the average value of a function. So one of the main application of the definite integral is to find the average value of a function y is equals to f of x over a specific interval a to b. So in order to find this average value, one must integrate the function by using the fundamental theorem of calculus and divide the answer by the length of the interval. So the average value or the mean value of the function on the interval a to b is 1 by b minus a into integral from a to b f of x Now finding the average value of a function under the radical 4 minus x square on the closed interval minus 2 to 2. Let's draw this function. It is basically the shape of a semicircle. So we can find out the area under the curve by using the geometry formulas. So this is we know the area of a semicircle, which is basically pi r square by 2. Here the value of radius is 2. Substituting the value of r in the expression, we get 2 pi. So this is the answer of integral minus 2 under the radical 4 minus. So multiplying it with the inverse of the interval length of the interval, we get pi by 2. So the average value of the function under the radical 4 minus x square on the interval minus 2 is pi by 2. Now after listening to this whole theory of integration, you can solve the exercise question and practice more questions on this topic.